Hello students, and welcome to another video. Today we're going to be discussing chemical calculations and stoichiometry. And please write down this definition. Okay, a mole ratio is a conversion factor derived from the coefficients of a balanced chemical equation. Okay, and it's interpreted in terms of moles. So if you look down here at this chemical equation, right, we've been using this in the last couple of videos. We've had nitrogen, hydrogen forming ammonia, right? And if we notice, the coefficients are different for each of these. For 1 mole of nitrogen, okay, you can make 2 moles of ammonia. And for 3 moles of hydrogen, you can only make 2 moles of ammonia, right? So there's these different amounts of these reactants to create our product, okay? Now, if we scroll down a little bit here, okay, now we can see it in model form. So the mole ratio is the coefficient. So to make ammonia, you need 1 mole of nitrogen. Then nitrogen and hydrogen are both diatomic, so they exist in pairs. So 1 mole of diatomic nitrogen, you need 3 moles of diatomic hydrogen. Okay, to make 2 moles of nitrogen or ammonia, you're going to need 1 mole of nitrogen. Okay, it's going to split into 2. Now, the final one, to make 2 moles of ammonia, you need 3 moles of hydrogen. So let's observe this graph on this left side. We have 2 slopes. One is representing the reactants of nitrogen and hydrogen. And from these slopes, we can tell that you're going to need less ammonia to make, less nitrogen to make ammonia than hydrogen. So for example, if I had 6 reactants or 6 moles of either substance, I could make 12 moles of ammonia, or I could make 4 moles of ammonia if it was hydrogen. Okay, so all we're doing is we're comparing these slopes to the ratios of the reactant to the product and the reactant to the product, because there's 2 reactants in this equation, right? We have nitrogen and hydrogen forming ammonia, and this is just showing that representation of that ratio, okay, in comparison to the products being formed. So let's turn the page and let's work through a problem together, okay? I'm going to ignore this part up here. It's a little confusing, might be hard to follow, but let's go down here to the second part, okay? So we're going to write out a balanced equation. So we're going to form hydrogen and oxygen are going to combine to form water, okay? And we're given a quantity of water. Now, if we look at this problem, it says how many moles of oxygen would you need to produce 25 moles of H2O from the reaction of hydrogen and oxygen? So you have a given amount of water that is going to form, okay? But how many moles of oxygen would you need to produce that amount, right? That's the question we're asking. We're asking, how much oxygen do we need to produce 25 moles of water? Okay, so we have our given amount, which is 25 moles, and we need to find that mole ratio in order to get to where we want to find the amount of given oxygen. These are our mole ratios, okay? They can be written either way, right? Because it's a proportion. Proportions can be written either direction. It's like I can say, I can drive down the road 40 miles per hour, or I can say in 1 hour I can drive 40 miles. You can say it either way. It's a proportion. We're making a comparison, okay? So for 2 moles of water, I only need 1 mole of oxygen. So in this equation, I use this ratio because it makes sense to what we're using. So we set up our picket fence, right? We have our 25 moles of water, and we're going to be comparing it to our ratio of 1 mole oxygen to 2 moles of water, and our moles of water cancel, and that gives us 12.5 moles of oxygen, okay? This should feel like a kind of an easy problem based on all of the math we've learned, okay? That's why I'm not going in super extreme depth on this problem, okay? Because you can frame this so that the given amount cancels out with this ratio, and it equals 12.5 moles, which makes sense because you only need half the amount, right? Because 1/2, do you see it's 1/2 of 25 is 12.5. So you can kind of pick that out there, okay? Thanks for watching.